All right, today we're cracking open the hood on the AI that's powering self-driving cars. And we're not just going to look at what they do, we're going way deeper to understand how a new kind of architecture lets these things actually think, and, what's really crucial, explain their own actions. So to really get this, we've got to start with a huge problem, one that's been holding back autonomous systems for years. It's really a problem of trust, and it all boils down to one simple question. I mean, you see these cars on the road, navigating these incredibly chaotic situations, making thousands of little choices every single second. But how? How do they actually make a split-second, life-or-death decision, like whether to brake or to swerve? And for the longest time, the honest answer was, we had no idea. See, the traditional systems, they relied on these deep neural networks. Super powerful, yeah, but their internal logic, a total mystery. And this black box is a massive, massive barrier. Because think about it, if you don't know why a car made a mistake, how in the world can you ever really trust it? But that's all starting to change. There's a new blueprint emerging that finally cracks that black box wide open. And the secret is giving the AI something totally revolutionary, its own internal monologue. Okay, so the classic way to think about this was a simple little feedback loop. You've got the agent, the AI, that takes an action in the environment, gets back an observation, and then acts again. Simple. But look at this new architecture. They've jammed something brand new right in the middle. Thought. This isn't just a background process. It's an explicit, internal reasoning step where the AI literally stops and thinks about what it should do next. So the real shift is right here. In the old systems, thought was, well, it wasn't really thought. It was just an implicit mathematical tweak based on getting a reward or not. But in this new model, a large language model, yep, the same kind of tech in advanced chatbots, is the brain. And it uses what's called chain of thought reasoning. It literally talks itself through the problem, step by step in natural language. It's the difference between learning by pure instinct versus actually thinking through a plan. So when we say this AI thinks, what are we actually talking about? It's not just one magic trick. It's more like a whole cognitive engine that's built on three really fundamental pillars. So these are the core abilities, right? You've got planning, which is all about taking a big goal, like get to the grocery store, and breaking it down into hundreds of tiny manageable steps. Then there's memory, which is about using past knowledge, like remembering a tricky intersection you've been through before. And finally, action, or tool mastery. This is the AI knowing exactly which sensor to check or which command to use at the perfect moment. And the memory part, it's actually a lot like ours. The AI has a short-term memory, which lives right inside the LLM's active mind for what's happening right now, like that bicycle that just appeared on the right. But it can also tap into a huge long-term memory stored in an external database for all that general knowledge, like traffic laws or the fact that people tend to jaywalk. And this is where things get really, really smart. It's a total game changer for efficiency. In older cars, every single sensor might be running full blast all the time, just burning through power. But here, the LLM's reasoning engine is more like an orchestrator. It thinks, I only need to check my left side camera right now, and it activates just that one tool, saving a massive amount of energy. So how does this all actually work together? Well, it all comes together in this brilliant framework called REACT. And it's basically a simple but incredibly powerful recipe for turning thoughts into real-world actions. This is the rhythm of its mind. It all starts with a thought. Okay, I need to change lanes. That thought triggers an action. Let me check my blind spot sensor. The sensor gives back an observation. The lane is clear. And that observation kicks off the next thought. Great, it's safe to start moving over. This cycle, thought, action, observation, just keeps repeating over and over, letting the car constantly adopt its plan on the fly. And this is the real payoff. Because this whole process, every single thought, every action, every observation, is in plain language. It creates a log, a perfect, readable, auditable trail of its reasoning. For the very first time, we can actually ask the car why it did something, and it can literally show us its work. Now, this all sounds amazing, right? But it's not perfect. This new architecture is still facing some major hurdles, and it's not without its challenges. And the number one challenge is this classic balancing act. You have this deep strategic reasoning, which is super powerful, but it's also slow, and it costs a lot of computing power. On the flip side, you have simple, fast commands, but they don't have that high-level intelligence. The trick is finding that sweet spot right in the middle. The solution is a clever hybrid approach. You let the big LLM brain handle the grand strategy, like figuring out how to merge onto a busy highway. But for those split-second, hit-the-brakes-now moments, you have a specialized, lightning-fast system that can take over and react in under 50 milliseconds. It's like the LLM has a co-pilot with superhuman reflexes. And get this, at the same time, the strategic part of the brain is getting smarter about being smart. Using advanced techniques, the AI can actually look back on its own thought process and go, I could have figured that out way faster in 3 steps instead of 5. That self-correction is huge. In some tests, it's cut down the computational cost by over 58%.
So what's the end game for all of this? It's something called explainable sequential decision-making. Now, that's a fancy way of saying we can understand not just a single decision in isolation, but the entire story of how the AI's reasoning unfolded over time. And that is everything when it comes to building systems we can actually prove are safe and trustworthy.
Look, this architecture is a truly monumental step forward. It's getting us closer to a more general, more human-like intelligence. By finally cracking open that black box and giving the AI a voice, we've solved an enormous technical problem. But it leaves us with one last and maybe the most important question of all. If the black box is finally open, are we ready to look inside and trust what we see?